Hello class, my name is Alexis Bennett. I am presenting for Data 625, Data Visualization. This presentation is titled Network Security Risk Assessment Using Network Graphs. I am representing a cybersecurity consulting firm, and today I will be sharing my assessment of two client communication networks, Network 2 and Network 3, similar to our Network 1 analysis, using network visualizations and betweenness centrality analysis. Just to kind of start in terms of the overview here, just to kind of give a quick introduction. This is going to consist of, well, three being the network one, which you can see in my executive summary, but this specifically will include both the network visualizations created in Tableau. And just to kind of transition into network two. So here it has the same number of users as network three. So both of them have the same number of users. However, the structure is noticeably different. This network is more distributed, meaning influence is shared across multiple nodes rather than a concentrated or a single hub. In this network, the node specter and the highest betweenness centrality with shadow and stealth also serving as important intermediates. Um, this is reflected visually through larger node sizes and darker colors, following Tableau's design, and then also the YouTube reference design principles where visual hierarchy communicates analytical importance. From a cybersecurity perspective, Network 2 is very robust or moderately robust. If a peripheral node were infected with malware or taken offline, communication would largely continue through alternative pathways. However, if the central node, like Spectre, were compromised, malware could still spread across multiple groups. So my recommendation for this client is to strengthen monitoring and security controls around the high betweenness nodes while preserving the redundancy that makes the network relatively resilient. Transitioning into network three, uh, although Network 3 contains the same number of employees as Network 2, it exhibits a very different structure. This network follows like a hub and spoke model, which we referenced in chapter 12, or maybe my own research, but I believe it's in chapter 12, where communication depends heavily on a small number of critical nodes. The node Nebula has the highest betweenness centrally, but not only in this network, but across all three networks that were analyzed. Nodes such as Zenith and Quantum also play key intermediary roles, but Nebula is the primary connector. From a security standpoint, Network 3 is very fragile or highly fragile. If Nebula were to become infected with malware or taken offline, entire sections of the network would be disconnected and communication would fail. So, my recommendation for this client is to reduce reliance on single hubs, introduce redundancy, and prioritize protective controls around critical nodes. So, in terms of the overall assignment, I made the assessments based on betweenness, centrality, network layout, and visual patterns observed in Tableau. Although both networks have the same number of employees, their risks are not comparable. They're not the same. Network two distributes communication across several intermediaries, making it more difficult or more resilient to failure. Network three, while efficient, concentrates risk in a few keynotes, dramatically increasing its vulnerability to targeted attacks. So in my visualizations, I apply consistent color gradients, node scaling, and filtering techniques inspired by the Sophie Hiscock video. Of course, I did add the annotations here just to make it easier for visual purposes. So by example, you could filter by the relationship field, which I don't know if you can see here, but and with the wildcard searches, it allows us analysts to isolate all communications involving a single user, which is invaluable for threat investigations. So in conclusion, Network 2 represents moderate risk, while Network 3 poses as a high cybersecurity risk, despite having the same workforce size. And of course, this conclusion here just kind of speaks highly to that. And of course, by applying the principles we learned in Chapter 12, these visualizations transform intricate network metrics into engaging and easily understandable stories. So thank you for your time. This concludes my network security assessment. I welcome your feedback. Thank you.